Hey guys, it's Mr. Katz. We're going to give you a little bit of help with Lesson 11. This is definitely not everything we've done in Lesson 11, but hopefully this will clear up some misconceptions. All right, so two things we're going to do. We're going to do a couple of the homework problems that you had for Lesson 11, and we're going to do them out. And then we're going to also do a problem where you have to do a conversion between forms if you're given an equation. Um, so the ones that we're going to do are the homework number 7 and 8. This one gives you a formula already in standard form, and it asks you to put it in vertex form and then also again in factor form. It asks you to show a table and then graph it. So it's in standard form already. So I can put it in vertex form by going ahead and finding the vertex. So either I could have used my calculator, or the formula negative b over 2a will get us the x-coordinate of the vertex. So this is the b, this is the a is negative 1. So negative b would be negative 10 over 2 times negative 1, which is negative 2. So we get our x-coordinate of our vertex is 5. And our y-coordinate, if I plug a 5 in, you get negative x squared, so negative 5 squared, plus 10 times 5. Remember, it's like this. 10 times 5, and then minus 25. So negative 5 squared is 25, so you get negative 25 plus 50, which gets you 25. And 25 minus 25 gets you 0. So our vertex is at 5, 0. So vertex form I can write, because we know right here in front of the x squared, the a is negative 1. So that helps us know that the dilation is 1, but there is a reflection. So we put a negative sign in front of our parentheses for the reflection of negative 1. And it is, you use your vertex. So the vertex is at 5, 0. So it's the opposite. So it's going to be 5 minus 0. I'm sorry, x minus 5 squared. And then the 0 means we don't move the vertex up or down. So I don't really have to put a plus 0 or minus 0. You can just leave it like this. And this is vertex form. Factored form, I have to go back to the standard form. And I'm going to factor our expression. Or actually, it's an equation because y equals. So when you have an equation, negative x squared plus 10x minus 25, the a is actually not 1. It's negative 1. So we do have to multiply a and c, which is negative 1 times negative 25. We get 25. We're looking for the two things that multiply to 25 that add to 10. That's 5 and 5. So now we're going to write it as a 4-term polynomial, because we have to go the long way in factoring. Plus 5x, another plus 5x, because those are the two numbers we found, 5 and 5, and then minus 25. Now we're going to group these two and these two together. The greatest common factor of this group is x. I'm left with negative x plus 5. Greatest common factor here is a 5, but we're left with x minus 5. You'll see that inside the parentheses, it's the opposite. So in order to change that, I'm going to factor out a negative 1. So I put a negative 5, and I'm going to change everything in the inside of the parentheses to the opposite. Now I have the same thing written inside. So I can say my factors are x minus 5, the things on the outside of the parentheses, and the stuff inside the parentheses, which is negative x plus 5. So I can use this as my factored form. Y equals x minus 5 times negative x plus 5. Now remember, we said that you just have to be careful, because in factored form, you really don't know the dilation necessarily. It's not always going to be a number right in front of the parentheses. And here, even though you had a negative 1, you don't see that in either of these. So now it says show the vertex. Well, we know the vertex is at 5, 0. And a point left and to the right of it would be 4 and 6. And all you really have to do is you have to plug these x's in and find out what you get for y. And the easiest one that I think would be to use would be maybe the vertex form. So I plug a 4 in. 4 minus 5 is negative 1. Squared is 1. And you put a negative 1 times 1, which is 1. Here, if I put a 6 in, 6 minus 5 is 1. 1 squared is 1. And negative 1 times 1 is also 1. So there are 2 points. And then to graph it, I have 6, 0, 1, 2, 3, 4, 5, 6. I'm sorry, 5, 0, 6, 1, and 4, 1. And then I could do a rough sketch of my parabola. So number 8, I'm not going to go too far into, but they're just a major concept that we have to think about. Even though you see your x-intercepts, that doesn't necessarily mean you could put it directly in factored form, because you might not know what the dilation is. This a dilation of 1? Is this wider than a normal parabola? Is this skinnier or thinner than a normal parabola? So just because you have these 2 points, some students think that you could say, oh, that means it's x. Remember, it's the opposite, x plus 3 and x plus 2. This would get us the 2 x-intercepts if this were our actual equation. But this would only be if we knew that this was a dilation of 1. So in these kind of problems, and this was a hard one to figure out, what you really want to do is you want to find out as many points as you know for sure. Like we know absolutely that this point right here is 4, 1, and this point right here is negative 3, 0, and this point right here is negative 2, 0, and this point right here is negative 1, 1. If we know for a fact that those are our points, we can actually put this in standard form using our calculator by plugging the points into L1. So we're going to go to stat. I'm going to go, well, let me clear out my calculator, second plus 712. I'm going to go into stat, and I'm going to go ahead and edit some statistics. I'm going to put in my x's and my y's right in here. Okay? So I'm just, I don't think this is going to work out because I don't know for sure if these are our actual points. But if I do put in negative 4, 1, negative 3, 0, so we have negative 4, 1, negative 3, 0. Then I think we also had a negative 2, 0. And the last point, I believe, was negative 1, 1. Now again, this is how, if we knew that these were the actual points, this would work out fine. But I just want to show you the process and what you do in order to write this in standard form, just to double check that you know what the dilation is. So you're going to calculate, so you go back to stat, you're going to go over to calculate, and then quad reg will give you the quadratic equation if it actually did form 1. And you can see right here that our dilation, is 0.5. So given this, we can write our quadratic in standard form as y equals 0.5 or 1/2 x squared, 2.5x, or 2.5x, and then plus 3. So at the very least, we can see that our y-intercept is 3. We can use this equation to find our vertex. And if you use this to find your vertex, it would be negative b, so negative 2.5, 2.5 over 2 times a, which is 2 times 1/2, which is 1. So our x-coordinate is negative 2.5. I'd plug it back in to find our y-coordinate. And once you find this, you can write this in vertex form, since you're going to have your vertex and you're going to know your dilation. In this case, it's 0.5. Now, this one will not, you might not be able to factor this, and if you can't factor this, then you're not going to be able to put this in factored form. So here's one problem that we learned. We learned how to change different forms of equations into other forms. So here is almost a factored form. The reason I say almost, and sometimes this is accepted as factored form, but what I like to do is if there's a negative sign outside the parentheses, we're not so sure. In this case, it will be, but we're not positive that this is actually, we don't know that this parabola is going to have a dilation and a reflection of negative 1. So what I like to do is distribute the negative sign into one of the parentheses. And now you can use this as your factored form. And now that it's in factored form, I could find the x-intercepts if I wanted to. Remember, you can set each of these equal to 0 to find the 2 x-intercepts, or the 2 places where the parabola is going to hit the x-axis. So if you solve that, you will end up getting x equals negative 4. And if you solve this one, x plus 6 equals 0, you will get x also equals negative 6. The other forms, to find them, we would first want to put it in standard form. So I'm going to do that in red. which means you're going to have to actually multiply this binomial times this binomial. And when you distribute the x and distribute the -4, you get negative x squared. So now I know that for sure that the dilation was -1. Negative x squared minus 6x, which comes from negative x times 6. Negative 4 times x is negative 4x. And negative 4 times 6 is negative 24. I can combine these two terms. And I have my equation in standard form now, y equals, obviously. And last, to put it in vertex form, I'm going to find the vertex, which would be negative b over 2a. So negative 10 would be positive 10 over 2 times negative 1, which is negative 2. So you get negative 5 as your x coordinate of your vertex. And to find out what b is, I'm going to plug it back into this equation. So instead of negative x, I'm going to do negative 5 squared minus 10 times negative 5 minus 24. So negative 5 squared is positive 25, but then you multiply it by negative 1, and you get negative 25. Minus, now negative times a negative, this is going to end up becoming plus 50 minus 24. Negative 25 plus 50 is positive 25. 25 minus 24 is 1. So our vertex is at negative 5, 1. So now I can write it in vertex form. Y equals, we know the dilation is negative 1. So put a negative in front of the parentheses. X plus 5 squared plus 1.